Welcome back, everyone, to the deep dive. Okay, today we are absolutely strapping in for, well, I think it's arguably the most fascinating tech deep dive of the year. We're talking about the official production-ready unveiling of Ferrari's first full electric vehicle, the Elettrica. And they didn't just, show off a shiny concept car. No, they dropped the full details, chassis, components, engineering at their Capital Markets Day, October 9th, 2025. Okay, I have to say, you sound genuinely thrilled about Maranello finally going electric. I heard this might just be your favorite technical story this year. So does that mean my pre-order's in? You're getting me one right. I love the optimism, I really do. But let's just say Ferrari's probably prioritizing building these amazing machines over, well, corporate gifting right now.
Right.
But we are definitely going to analyze this engineering marvel.
Absolutely. And our mission today really is to unpack those core engineering principles. And the sheer amount of proprietary tech, they're talking over 60 patented solutions here that Ferrari developed, all to make sure this car delivers, that authentic, visceral driving experience, even without the usual V12 soundtrack.
Yeah, that context is so important, isn't it? Because the source material really paints this as a major philosophical shift for them.
It really is. It's the culmination of their whole multi-energy strategy. And crucially, they're introducing it not as some bare-bones two-seater hypercar, but as a four-door, a car designed, they say, to be enjoyed with family and friends.
A four-door Ferrari. I mean, doesn't that just sound almost contradictory, for a brand built purely on performance? How are they squaring that circle?
Well, it forces them to redefine performance, doesn't it? Ferrari was very explicit. They waited. They waited until the technology was mature enough to guarantee, yes, superlative performance, but also repeatable performance, and crucially, expand that usability. So the engineering choices, they reflect this mandate. Balance raw speed with, well, daily function.
Okay, all right. Let's dive into the numbers then. The headline figures. Oh, they're exactly what you'd expect, really. Over 1,000 CIV, that's horsepower in boost mode, which translates to 0 to 100 kilometers per hour in just 2.5 seconds.
Wow.
And a top speed capping out at 310 kilometers per hour.
Those are strong numbers, absolutely. But what's really fascinating is the thinking behind them. Look at the weight, around 2,300 kilograms. Now, that's heavy, yes, no denying it. But that weight is sort of a necessary trade-off because they prioritize handling precision, cornering capability, and really importantly, long range. They weren't just chasing those, 2,000-plus horsepower or hypercar stats that grab headlines. They seem to be optimizing the feel of driving, the repeatability, not just one terrifying launch.
Right, so the weight supports that grand touring mission. And that big battery, 122 kilowatt-hour gross capacity unit, that gives it a specified range of over 530 kilometers. That's genuinely useful GT range, isn't it?
Exactly, really practical. And managing that kind of mass, well, it demands a completely new structural core. And this is where those 60-plus patents you mentioned earlier really come into play. Because Ferrari developed and built the motors, the inverters, the entire battery pack themselves, in-house in Maranello.
Okay, let's talk about that battery and chassis integration. That seems like the heart of it. How did they take the battery, usually just dead weight, right? Make apart the structure.
Yeah, that's the clever bit. They built the battery right into the floor pan. It actually serves a structural protection function for the cells inside. And this integration method, it minimizes the combined weight of the battery and chassis system. And the dynamic payoff, it's huge. It lowers the center of gravity by a full 80 millimeters compared to an equivalent ICE car.
80 millimeters. Wow, that's a massive shift downwards.
It really is. And it leads to this optimal weight distribution. 47% front, 53% rear. Very balanced. They achieve that in part by putting 85% of the battery's weight in the absolute lowest possible position. And if you look at just the electrical side, they've hit a record-breaking total power density, almost 195 watt-hours per kilogram, which the sources are calling best in class for this kind of performance electric car.
And, being a Ferrari, it's not just about performance today. It's about longevity, lasting forever, as they like to say.
That's right. That longevity piece is core. They specifically engineered the battery to be removable and fully repairable, which means down the line you can replace individual modules or components. It really adheres to that Ferrari tradition of maintaining the car's heritage.
And this focus on heritage even connects to sustainability, which seems like a really key integration here.
Absolutely. The chassis and body shell, they're made using 75% recycled aluminum, which, get this, saves about 6.7 tons of CO2 for every single vehicle built.
That's incredible.
Yeah, and the castings, those vital structural parts, they use a secondary aluminum alloy. That cuts CO2 emissions by up to 90% compared to conventional alloys. So their sustainability effort is directly linked to that forever EV idea, making sure the structure lasts as long as the mechanics.
Okay, let's pivot a bit. Driving experience. And the big, notorious problem in EV design, NVH. Noise, vibration, harshness. Because electric motors are so quiet, right? All those other little sounds, road rumble, suspension noise, they suddenly become really noticeable, potentially ruining that luxury feel.
Exactly. And that raises the big challenge. How do you filter out all that unwanted noise and vibration without sacrificing the precise stiffness you need for that legendary Ferrari handling? You can't just, slap thick rubber everywhere and call it a day. It'd handle like a boat.
And their solution, for the rear axle at least, sounds pretty revolutionary for them. The first separate elasticized mechanical subframe in Ferrari history. Wait, hold on. They created the largest single-piece hollow casting they've ever produced, just to isolate tire noise. That says a lot about the commitment to comfort, doesn't it?
It really does. They developed this massive, complex casting for the subframe, and it uses these strategically placed elastomeric bushes. Think of them like highly engineered vibration sponges. They filter out the rolling noise from the tires and vibrations coming from the electric axle itself. But the genius part is, they designed it to maintain that super high lateral stiffness needed for sharp cornering, while allowing just enough vertical and longitudinal flexibility to smooth out the ride. Comfort and control.
So it's like building a bridge, almost. Incredibly rigid side to side for handling, but just soft enough up and down to kill the noise. That sounds like a massive engineering headache for what might seem like a small gain in comfort.
Precisely. And remember, this is just one piece of the whole dynamic control puzzle. This car has 4 independent motors, one for each wheel. That's coupled with 4-wheel steering too. The rear wheels can adjust their angle up to 2.15 degrees.
And then we've got the third generation of their 48-volt active suspension system, the one evolved from the Purisong and the F80, right? This car must be thinking ridiculously fast.
Oh, it absolutely is. The vehicle control unit, the brain, it updates all the dynamic parameters 200 times every second. This total active control lets the car predictively manage all the forces, vertical, longitudinal, lateral, on all 4 wheels, independently and constantly. It's basically real-time management of inertia, grip, everything.
Okay, let's look under the hood, so to speak. The motors. 4 of them, but they're not all the same, are they? How did they use that Formula One tech to make the axles so different?
Right. They definitely leveraged their F1 know-how, particularly using Halbach array rotors in the motors. Now, for anyone not familiar, a Halbach array is this really specialized arrangement of permanent magnets. It massively boosts the magnetic field on one side while almost canceling it on the other. This lets you get huge power density from a really small, compact motor. F1 stuff.
And they applied that compact tech very differently front and rear.
Exactly. The front axle gives you 210 kilowatts of power. It features these incredibly high rotational speeds, 30,000 RPM. And the integrated inverter there is key. It delivers over 300 kilowatts, but only weighs 9 kilograms. Meanwhile, the rear axle, well, that's the powerhouse. It produces a maximum of 620 kilowatts. And get this, it can deliver 8,000 Newton meters of torque to the road in performance launch mode. Just immense. And impressively, both front and rear axles achieve a peak efficiency of 93%. Very efficient power delivery.
What's also pretty neat is that efficiency feature they built into the front axle, the disconnect system.
Yes, that's clever. It lets the car switch to pure rear-wheel drive mode. It can do it at any speed, typically during highway cruising, just to maximize efficiency. You don't need the complexity of a mechanical gearbox disconnect.
And the driver controls that RWD selection through the E-Manatino switch. They claim the whole system is 70% lighter than the previous generation tech they used. And it engages or disengages those front motors in just 500 milliseconds, half a second, using that sophisticated gear synchronizing tech borrowed from their best transmissions.
And interfacing with all this complex machinery, the driver uses this dual control setup. You've got the traditional Manatino dial on the steering wheel. That handles the dynamic systems. They've even added a new dry mode, slotted between wet and sport, going all the way up to ESC off, naturally.
Right, and then there's the E-Manatino switch, which handles the energy side, range, tour, performance modes, controlling power delivery, and that RWD-AWD selection we just talked about. But the feature that sounds like it truly tries to capture that classic Ferrari sensation is something called torque shift engagement.
Yes, this is pure Ferrari thinking. Very clever. The driver uses the paddles behind the steering wheel, but instead of shifting gears, they select one of 5 progressively higher levels of available torque and power. See, idiots usually have this instant flat torque curve, which is fast, yes, but can feel a bit uninvolving compared to a revving engine building power.
Okay, so Ferrari uses the instant response of the electric motors to kind of smooth out the jumps between those 5 levels, managing the output really precisely.
Exactly. The key is how smoothly the system manages that transition. Any momentary dip in torque you might feel during a shift is basically imperceptible. It successfully simulates that feeling of deep involvement, that relentless, continuous thrust you get from a high-revving V12 with a super-fast dual-clutch gearbox. It's recreating that signature Ferrari acceleration curve, that feeling, but electrically.
Which brings us, finally, to the elephant in the room. Sound. I mean, how does a Ferrari EV sound? That engine note is so fundamental to the brand's identity.
Well, Ferrari's solution here is brilliant, mainly because it's authentic. They didn't go for fake noises. Think of it this way. An internal combustion engine sound that's like a brass band, right? The sound travels through the air. An EV powertrain, it's more like an electric guitar. The core sound travels through the metal structure. You need an amplifier to really hear it properly.
Ah, okay. So instead of piping in some digitally generated V12 recording, they're actually amplifying the unique mechanical voice of this specific electric drivetrain.
Precisely. They installed a high-precision sensor and accelerometer right onto a rigid point on the rear axle inverter casting. This sensor picks up the pure functional mechanical vibrations of the powertrain components, the motors, the gears, as they actually work. These vibrations are then amplified and projected outwards. And crucially, the sound only activates when it's functionally useful. So when the driver actively requests torque hitting the accelerator, or using those manual paddle shifts to the torque shift engagement, it provides that essential aural feedback. But when you're just cruising gently, silence is preferred, maximizing acoustic comfort.
So the result is an authentic voice that's unique to this electric powertrain, making sound part of the driver involvement, not just some synthetic gimmick. That's pretty cool.
Absolutely.
That's
So to sort of wrap it up, the Electrica really is a showcase of completely integrated in-house engineering. They clearly waited patiently for the technology to meet their standards. And the result is a system that prioritizes precise handling, that total dynamic control and longevity. A four-door GT, yes, but one that truly reflects the dynamic DNA of Ferrari.
Which leads me to a final, maybe provocative thought for you, the listener, to chew on. Given Ferrari now has this complete active control, vertical, longitudinal, lateral forces on all 4 wheels, all managed independently, updated 200 times a second, what kind of dynamic limits or maybe even driving possibilities does this total control unlock? Things that were physically impossible even for the absolute best, most advanced ICE supercars just a few years ago. We're talking about managing physics in real time in ways we haven't really seen before. What does that mean for the future of driving? That is a question worth pondering. Maybe I should buy that Ferrari after all, purely for research purposes.
Yeah.
Test those limits. See, I knew it was your favorite. If you do manage that, just remember who called shotgun first. Okay. Ha. Deal. Anyway, thank you all for joining us on this deep dive into Maranello's electric future. It's been fascinating. And if you want to keep up with the latest in this kind of groundbreaking tech and analysis, please do make sure you follow the channel. That way you won't miss any future explorations and updates. Thanks for listening.